Neutron stars are among the most extreme objects in the universe, remnants of collapsed stars with immense gravity and bizarre physics. So, what would actually happen if you fell into one? It turns out the answer depends on exactly how you fell into it. Let us say you were far away from the neutron star when you began your fall and that you were moving relatively slowly. As you started to get closer, you would notice the star's gravity pulling you in. But because it's so dense, its gravity would be thousands, if not millions times stronger than Earth's gravity at the same distance. That means, as you got closer, the gravitational force on you would increase dramatically, eventually overcoming any other forces like the air currents or your own muscle strength. At some point, the neutron star's gravity would start to stretch you out like spaghetti. That's because gravity pulls more strongly on the parts of you that are closer to the star, and the parts of you that are farther away experience less gravity. And as you get closer and closer to the neutron star, this difference in gravitational pull would become more extreme. The part of you closer to the star would be pulled in faster while the farther part resisted more, stretching you into a long, thin noodle. But as you continued to fall, things would get even stranger. At some point, you'd cross the event horizon, the boundary of no return around the black hole. Once you cross that, not even light can escape the pull of the neutron star. From this point on, you wouldn't be able to see anything coming to rescue you, nor would you be able to see the surface of the neutron star as you approached it. All you'd see is the darkness of space. At this point, the only thing keeping you together is the intense pressure keeping you from being crushed by the incredible gravity. But as you approach the center of the neutron star, that pressure would eventually be overcome. And at that point, you'd be utterly crushed and vaporized, completely obliterated by the intense gravity of the neutron star. Now let's say you weren't so far away when you fell. Instead, let us say you were already close enough that the neutron star's gravity was comparable to Earth's gravity. In this case, as you fell, the intense gravity would make it incredibly hard to move, like trying to walk through molasses. Because of the intense gravity, even small movements would take Herculean effort. As you got closer to the neutron star, the gravity would increase until every step you took was like moving a mountain over an atom's width. Eventually, the gravity would become so strong that it would start to tear you apart. But unlike the previous scenario where you were stretched out like spaghetti, in this case, the gravity would be so intense that it would crush you into a pancake-like shape. Then once you crossed the event horizon, the only thing keeping you together would be the intense pressure supporting you from being crushed by the extreme gravity. But as you approached the center of the neutron star, that pressure would eventually be overcome and you'd be utterly crushed and vaporized. So there you have it. Two equally grim fates awaited you if you fell into a neutron star. Total obliteration if you fell from far away and utter crushing if you fell from close up. But honestly, these scenarios are just speculation based on our current understanding of physics and neutron stars. We don't really know what would happen because we've never actually fallen into one. If anyone ever claims they've fallen into a neutron star, you can be pretty sure they're full of it. After all, falling into a neutron star is a one-way trip with almost no chance of survival. So, it's highly unlikely we'll ever have any first-hand accounts of the event. However, scientists are actually working on simulating these scenarios using supercomputers to better understand the behavior of matter under extreme conditions. These simulations could help us learn more about the physics of neutron stars and the behavior of matter under extreme conditions. But let us hope we never have to find out the hard way what happens if you fall into one. Thanks for watching this episode. If you want to help us make more videos like this, you can join our support page.